In this video, we shall be discussing on the expectation and variance of the normal distribution. In our previous video, we've already obtained the moment generating function for the normal distribution. For more on this topic, you need to subscribe to this channel. And here, we will now obtain the expectation and the variance for that moment generating function. We should recall that we got for our moment generating function, we got E sigma squared t squared all over 2 plus ut. This is what we got as the moment generating function from the normal distribution. So how do we obtain the expectation? Solution. We should remember that our variance of x is equal to the expected value of x squared minus the expected value or expectation of x all squared. So for our first moment, if we want to calculate for this first, it means the moment generating function, the first moment with respect to t, which is equal to the expected value of x is equal to, now we have this function. So we use what is called function of a function from differentiation to calculate for the differentiation, the first derivative of this function. So since this is our function, all we need to do, we say let u be equal to sigma squared t squared all over 2 plus ut, and our y is equal to exponential u. So all we need to do is to differentiate this with respect to t and differentiate this y with respect to u. So we will now arrive at, we'll get something like the y all over the t will equal to the y all over the u multiplied by the u all over the t. This is also equal to this. So the next thing to do is to come here. The u all over the t will give us, if we differentiate this function, since we are differentiating with respect to t, we get 2 sigma squared t 2 minus 1 all over 2 plus, if we differentiate this with respect to t, we'll get just u. So this thing is also equal to, this will cancel this, it will give us sigma squared t plus u. This is what we get for the u. Then we differentiate y with respect to u, which will give us this same function. That is to say, the y all over the t, which is this, which is also equal to the first differential of this is equal to the y all over the u. The y all over the u is eu multiplied by the u all over the t. The u all over the t is sigma squared t plus u. And we should note that our u is equal to, our u is this, sigma squared t squared all over 2 plus ut. It then means that our first moment x t is equal to, we impute this u into this to give us our final answer to be e raised to the power of sigma squared t squared all over 2 plus ut multiplied by this function, sigma squared t plus u plus mu. This is what we get. So we can write here as, we can write it as sigma squared t plus mu multiplied by exponential t squared all over 2 plus mu t. So this is what we get. This is mu. This is mu. And this is mu. So this is what we got. It means that the moment generating function, the first moment, which is the expected value of x, is equal to sigma squared t plus mu exponential sigma squared t squared all over 2 plus mu t. So this is what we got as our first moment. But at t equal to 0, at t is equal to 0, which is the expected value of x, is equal to, anywhere we see t, we put 0. We have sigma squared 0 plus mu exponential sigma squared 0 squared plus mu multiplied by 0 all over 2. So the whole of this will give us mu multiplied by, this is 0 already, so everything is 0, mu multiplied by 1. So it then means that our expected value is equal to mu. The next thing to do is to take the second derivative. We take the second derivative. This is our first derivative. So we take our second derivative. To take our second derivative, we move over to this place. We move over to this place. For more on this topic, you need to subscribe to this channel. So to take our second derivative, which is the second derivative for the moment generating function, which is the expected value of x squared, is equal to, we use this time the product rule because a function is multiplying another function. So this is our u and this is our v. That product rule states that u dv all over dt, because you are differentiating with respect to t, plus v du all over dt. So what is our u? This is our u and this is our v. So our u, we bring it down, we get sigma squared t plus mu. The v all over the t, the v all over the t, we have differentiated this before. If we differentiate this, we get the whole of this function. That is what we got. When we did this, we got the whole of this function when we differentiated this. So it means multiplied by sigma squared t plus mu exponential sigma squared t squared all over 2 plus mu t plus v. What is our v? This is our v. We have sigma squared t squared all over 2 plus mu t multiplied by the u all over the t. The u all over the t. If we differentiate this with respect to t, this will go off. This will turn to 0. This will go off. We will now be left with just sigma squared. We differentiate the whole function with respect to t because this will now be 1 minus 1, which is 0. Anything raised to the power of 0 is 1. So 1 multiplied by this, we'll have sigma squared plus 0. So this is what we'll get. It then means that our second derivative is equal to this function. Is equal to this function. So at t equal to 0, that means the second moment equal to 0, which is the expected value of x squared, is equal to, anywhere we see t, we put 0. So we'll have sigma squared multiplied by 0 plus mu, sigma squared multiplied by 0 plus mu, and exponential sigma squared 0 squared all over 2 plus mu multiplied by 0 plus sigma squared 0 squared all over 2 plus mu multiplied by 0. This is t. Multiplied by sigma squared. So this is what we get. We still come over to this place. We still come over to this place. Our first moment is mu, so we can delete the whole of this. We can delete the whole of this. And leave our first moment. So the next thing, the second derivative, which is equal to the expected value of x squared, is equal to, of course, this is 0, so we'll be left with mu. We'll be left with mu. This is 0, we'll be left with mu again, multiplied by mu. This is 0, so this is 1, multiplied by 1 plus, the whole of this is 0, so this, anything raised to the power of 0 is 1. The whole of this is 0 multiplied by sigma squared. So it will now be plus, the whole of this is 0, which is 1 multiplied by sigma squared. So we are left with mu squared plus sigma squared. Of course, if we want to put it, our variance of x, we've already calculated the expectations. Now the variance of x is the expected value of x squared minus the expected value of x all squared, which is also the second moment of x minus the first moment of x all squared. And we have this as our mu squared plus sigma squared. Bring down the sign, minus mu all squared. So we have mu squared plus sigma squared minus mu squared. Of course, this will cancel this. So what we now have here is our sigma squared, and this becomes our variance. So the variance is sigma squared. The variance for the normal distribution or our continuous case is sigma squared, while the expectation of x is mu, and the expectation of this is mu squared plus this. So for more on this topic, you need to subscribe to this channel. This is simply how we can get the expectation and the variance for the continuous case of the normal distribution.